We are picking up from the previous video where we have created our first project and our first rifles for the 6.5 Creedmoor. In this video, it's all about showing how to create the first session, which includes obviously the creation of the recipe, which is a critical element, and then going all the way to shooting the session, collecting the different variable velocities and the target size, and then we generate a report. So let's go. I'm going to look for my project. I click project, click on the project itself, and here I will be landing on the normal project page where I can see the session list here. I can do load simulation, chart ladder, sitting desk, distant validation, shooting with data, all sort of type of session that will be explained in different other videos, or you can use the learn section, which is here to find how to use Primox. So here we're going to do a charge ladder, a standard charge ladder. So I'm going to go charge ladder. Here we have multiple options. We're not doing a simulation calibration. We're doing a standard charge ladder, which is already selected. And I'm not going to shoot that all in one target. Each of the individual loads will have their own targets because I want some clarity and I want to have 3 shots for each of the loads. This is why you have the symbol here helping you to find out what is the difference. We will cover the shared target in some other videos. Here we want to use a recipe, which is very important. And you can use it without the recipe, but that for when you actually not hand loading. Here we are hand loading and we're looking at what is for the powder that we have selected. Here we're going to test the 4350 from Oxen. And we want to find out if we have some interesting loads that would work good for us. So if we scroll down, we have our project, which is already selected. We will be at 100 yards. I will be using 3 shots per load. I don't care much about stop velocity. That will be explained in other videos. And here, we do not have a recipe yet because we haven't created anything yet. So we need to create a recipe first. I'm going to click plus. Here, I like to name the recipes with as much as information that I have, so it'll be easier for me to find it if I need to. For in our case here, I will name it 6.5 Creedmoor. We know what it is. We're using Lapua brass, the kind of bullet we are using, the primer, the powder we're going to use, then it's a version 1. You can add other information like your CBTO and other things, but we can start in a simple way like this. The project, it's already created. We can go and create some process template, which help you to track your reloading processes. There is a full part of Primox that's doing this. It's not covered in video, but it helps you to track all your reloading steps, step by steps, all the way to a fully loaded ammunition. Now the component. For this specific recipe, we're going to use Oxen 4350. So here, obviously, we haven't created anything yet. We're going to powder and we're going to create this powder on the fly. Clicking plus, I'm looking to pick it in the library. I will look for Oxen. And here it is, age 4350. I have all the information that I need from the database. I don't need to worry about any of these. I can create it new. We already have, because when we set up the project, we have the projectile, the brass, and the primer. If you don't have this information, you need to fill it up. Here, the CBTO we're going to use based on our measurement to be 20,000 from the land is going to be 2.146. And as you see, as I tap, new elements are coming up. If you know your COIL, you can enter it. For me, it's this one here, 2.890. And here you have many more information you can fill up for your own data collection, but at the same time, they will be very useful for your when you're going to use the internal ballistic engine that we have in Primox. So here, I'm not going to go through all of them. I have a bullet jump of 20,000. What is important for me here is the water capacity that I will use later on. And that's probably enough for now. I will then create the recipe. So you can see the recipe, it's everything put together, the component that we use, and also the preparation and the different measurements that we want to use, that we have collected. I can create the recipe. Now my recipe is automatically available here. We have it here. And I will start from this specific charge ladder, 40.6, all the way down to 42. And the step will be 0.2 grain. You can add multiple zone. If you have, after doing a coarse ladder, you want to do a fine ladder, and there is 2 or 3 different sweet spot you want to cover, you can add different zone from 40.6 to 42, for example, and from 43 to 44. And you can add as many zone as you want. Here we have all this information available here, and we have the Primox is telling us, I'm going to generate this load here. We can click next. Here we have some information regarding the session. You might have this information or not. Here at my range, I have no information on the temperature and the humidity yet. I can fill that up later on. It will be very useful for this session to capture this environment data. Then I can create a session. I have some safety warning that is letting me know that based on the data we have in our database, 42 grain is getting pretty high. That's too good information. We need to be aware of this. Now we are in the charge ladder session. And this is the main page where we're going to go through the 5 steps that's going to take us from the preparation of the load all the way down to the report. We have 5 steps. We prepare, then we prepare the session, then we do the range capture, which is basically capturing the velocity and knowing where the shot went. Same thing with the velocity, we can do that separately. And also we then mark the targets, mark all the shots in the targets, and then we get the report. So let's go through them one by one. The first thing, we have all the information about the session that we are going to do today, 100 yards, range, 3 shots for each of the load. The recipe has been selected. We have all our loads available here. And I can add some warm-up load as well. So in that example, I want to add more 41.4. I want to do 2 warm-up shots to make sure that my barrel is not too cold when we start the first load. So I'm going to click on this and I'm going to say, okay, I want to use 41.4 for this warm-up. I'm going to use 2 of them and I can add them. And then they will come in the list when we need them later on. And we can edit all this. Now we are going in the prepare phase. I'm going to click next step. And here we are asked what kind of sequence we want to use for this. Are we going to do the sequential, so all the load one by one, so 40.6, 3 shots and so on, or a round robin, or a round robin in a snake when we come back, which is the one I prefer for that kind of session. As we click this, we know that the order will be created for us and we can save the plan. The plan has been prepared. We have all the different sequence that we need for all the different load, and we can also create a PDF document that we can take to the range. That's going to help us to follow the plan if we want to write it down. If you want to use a range capture, you want to use on your phone or on your tablet, and you want to capture the information at the range, you can use Primox for this if you have reception. If not, you can do everything manually downloading the PDF documents, and I will do that now. This is how the PDF documents look like. We have all the information we need regarding the session. We have all the loads available, and we know when to shoot them one by one. So that's the overall load. We can record our conditions, and then we say we're going to start with a warm-up at 41.4 in the warm-up target, and then we're going to shoot A1 40.6 in target A, and then going to do B, and so on. We have all the information we need. Now we have done the preparation. It's time to go to step 2. So one of these flashing here, we're going to do the range capture. Range capture is selected. Now We can skip it if we want, if we don't want to capture the data live at the range, but I'm going to show you how to do that live here. So here, this is a warm-up shot, number 1, and we have all the information we need here. I recommend using a tablet for this. The phone, it's okay, but this might be a bit small. And here, we're going to go through step by step if you want, and you do not have to do this, but it's the easiest way to do it. So here for my first warm-up, it was at 2650, and I go next. Same thing here, the second warm-up was 2655, and we confirm this. As we enter target A, which is the first shot we're going to do for 40.6, we can enter obviously the velocity here. So let's say 26. You can, if you want to remember which shot went where, get a rough idea of when it went. You don't need to be precise and you don't need to do this, but it's very useful. You will see when it's time to find out which was the first shot and which was the second one and so on. Is quite useful. So here I can say, okay, this shot went here, for example, and I keep going all the way for all the shot one by one. So target A 40.6. Now we're going to switch to target B 40.8. And here, probably 2640. It wasn't a flyer, it wasn't a sighter. If I have some signs of pressure, I can record this. This will be very useful later on. And I keep on clicking and I do all this for all my shot when I am at the range. And I'm going to fast track the video here so we can have all the data at the end. After entering all the velocities and where the bullet landed, we ending up on this screen. It's really important to repeat that when we mark the shot on the screen, this does not have to be precise. It's only for us to remember where roughly the bullet landed. The precise measurement of where the bullet landed is done in the next phase that we will cover. Do not worry about not being precise if you want to get an idea of where which bullet 1, 2, or 3 for each charge landed. It's just to get an overall position for it, and you will understand why later on. So I've got the velocity, I've got roughly where the bullet landed, and now I can click on View Session to go back to the session. So we've done prepare, range capture, the velocity has been done. If you haven't done the velocity through the range capture, you can do it by hand based on the note you took at the range, and you will go to transcribe range card. It's not covered in video, but it's very easy to do. Now it's time to actually mark exactly where the bullet landed on each of the target. So I'm going to go to the next step, step number 4, target, and here I'm going to edit the shot. You would have taken photos of your target at the range. Here there is the one for mine here, and I will drag and drop the target. Obviously, this target is not really for the purpose of this demonstration, and then you will understand how we address all this. The first thing that is really important is the calibration. On your target, here we are at 100 yards. You need to mark what is 1 inches, 2 inches, 3 inches, whatever works for you, so we can do the calibration here, which is the first step. So first calibration here is we're going to mark the 2 inches. That's a distance, and you can obviously zoom, and it will be 2 inches here, and I can confirm this. Now I'm asked for all the load, except for the warm-up. So the point of aim for target A is obviously this here, and this is where we need to be precise. So now I'm asked to enter each of the shot one by one. And this is where the range capture, when we capture roughly where it is, we remember which one is shot 1 and shot 2 and shot 3. So I can zoom here and I will say shot 1 is this one here, based on one I'm looking at what have been recorded at the range, shot number 2, shot number 3. That's done for the first load at 40.6. And I keep on doing these for all the loads. So now I'm doing 40.8. The point of aim is this. And then the first one was at the top, and then the second one and the third one. Here, this is where you want to be precise. And obviously you can zoom even more. Now let's do 41 grain as well. Point of aim is here. And here they are very close. 1, 2, 3 from left to right. 1, 2, and 3. And we do this for all the load. And as you can see here, when I'm even marking D for 41.2, and I'm selecting the first one, here you can see at the top the velocity that we've recorded at the range, it's automatically filled up. You don't need to do that manually. Now we'll go for the second shot, and it was 26.35 feet per second. So all is coming together in one place. Finally, we are done. We can zoom out, and we have all the information that we need based on what we've recorded on the field. If you bring your data manually, you can do that, or you can do it automatically with the software. I also have some information about some pressure signs, but everything is available here, and we can modify all this. We can finally save all of it, and everything we've done from this session, it's available in the session. We finish all the steps from 1 to 5. We have all the loads with the average velocity for all of them, our SD, our ES, number of shots, everything is there with some pressure sign here as well. So the last piece of the puzzle is to finally view the report, and this is where we're going to click View Report. This is where the magic happened, and let's have a look at the report itself. So obviously we have the test summary of what we've done, 24 shots all up. The average is 26.58. We have all the data that we need. Pressure sign has been observed, which is very useful. And let's have a look at some of the graphs. Here I have all the impact put all in one place. I can deselect all. I can only see 40.6 and so on. If I want to see each of them, I want to see the shape or how they fit together. Very useful. Then I can see a detailed view of the velocity analysis. We have a bit of a flat bit here and a flat bit here. I can see also all the error bar, the different SD at the same time, everything you need. The overall velocities for each of the point, we have the information that we need with distribution and all different elements. The velocity distribution is also available, and also the different ES and SD for the different charges at different points. This 41.0 look interesting. Vertical group spread is very interesting too. So here we only look at what is the best in terms of vertical spread. 41 again is looking pretty good, and 42. And here we have the load summary where all the data that we want to see. So for example, for 41, we have a vertical of 0.9 MOA, a group size of 0.04. That's a vertical point of impact shift from one load to the other, which is very useful to find out is a load is not only stable in velocity, but also in point of impact. With here, we can confirm, for example, if we want to use the best stability one or rank number 241 for the more precision. We don't need to do that here. But that's the essence of what we have here. And then we have all our targets at the same time. This is a full report, and then you can decide what you want to do. If you decide you want to do a more finer test in different sweet spot, you can do another charge weight in different region, in multiple region. Back to the project view, we can now see that we have our session available here. Obviously, I can add other information later on, like, for example, the conditions. If I'm opening this session and I can edit the session and I have some information regarding the temperature and the humidity, I can add all this to make sure that my data is fully complete. To give you an idea of what else you get when you upgrade to the Pro version, let's have a look at the report. So this account has been upgraded to Pro. If we're looking at the report now, we have more details in the graphs and in the analysis. So for example, I can have a look for the shot placement. I can have a look at the center rate, basically the average of all the shots here. So here, if I want to have a look at where they are, I can see that 40.8 on average is here, and I can start thinking about, okay, what is the point of impact change through the different loads? Then the analysis here, it's the same for the velocity. Here, what is getting interesting is that, for example, we get a combined analysis of velocity and point of impact trend, where we have some interesting things that are happening here, where the point of impact is very stable here. So that's a node here that we can identify and think about. And we also have some other nodes here. So other information is available when we put the different analysis together. We have charge sensitivity, which is quite interesting in that area. And the really interesting one is the point of impact migration when we go from one load to the other. Where is the most stable area here, independent of velocities? So this is where this is renewed here. We have much more stability of point of impact in that area and in that area. So we might want to investigate these better. Same thing with the trend chart. Another way to look at it is the point of impact is much more stable here versus the charge weight. And we get some analysis here. Obviously, they are just recommendations. You need to be careful with your load, and depending on your application, some of this information will be relevant or not relevant to you. You can obviously go deeper into the analysis lab. So here's a more detailed way to scientifically analyze what you have if you want to go into more detail. So if you want to go deeper into velocity analysis, you can change all the different parameters. Let's say I want to add the mean radius here. I will see it. It's up to you to have a look at all the different options to fine-tune what you're looking for. Many options here. There will be a specific video just for the analysis lab. Finally, a way to get also all this together, it's to use the AI agent that will know about your data and will generate a summary. Obviously, it's all about you knowing your load and knowing what you're looking for. This AI summary is just some indications. We need to be careful with the information that we get here, but it's interesting to look at it and to read it to try to understand what kind of a different angle we would have missed here. Finally, one very important element that we'll have is dedicated video later on is the ability for you to calibrate the load based on the result and the velocity that you have captured. So in the what next section, just below the AI summary, we have the Calibrate Ballistic Simulator. Some information has already been filled up, but if it is missing, you will be asked to enter the right value. And the idea is to calibrate the powder and your load based on the velocity that you have captured. So here you go to calibration, and that will take us to the ballistic simulator. And here we have a disclaimer that we need to agree that we have to be very careful with pressure and always follow the manufacturer recommendations. So here we click that, and that will take us to, as you can see here, to the load simulator, and we go straight to calibration. When we land on calibration, what we see is that we have for each of the powder charge, the average velocities of our 3 shots. And thanks to this, we will be able to calibrate specifically the load, meaning the powder, for our future simulation based on all the information we have, which is quite precise. We know with the case capacity, the temperature, the average for all this load, that's going to help us to create much more accurate data for the load simulation. So here I will click Calibrate and Save. And the recipe, the load will be calibrated. So these are the new values that we have here. And we have the values that were measured compared to what would have been predicted. You can see they are actually now very close, -5 feet per second, because we have a lot of information with the this type of powder, H4350, with this type of bullet, with this type of cartridge, the simulator. A lot of calibration has been done already. The more data we have from the manufacturer, the better projection we have. And so it depends on the elements that you are using. So now if we want, I will quickly go to the simulator with this information, and I can decide that I can see the curve here. I can decide to change different value for 42 grains. I will know the kind of speed that I'm expecting. I would expect 2,700 feet per second, and I can do all sort of simulation, changing the temperature. Here we have a high confidence level because we have these calibrated properly. If I'm changing the temperature to much higher temperature, then the curve is changing. Specific videos will be provided for this, but this is a very key, very important element of every time you collect some data at different temperature, at different loads, in different conditions, you can recalibrate your powder, your system to your full rifle, to your full system. And this is one key element where we close the loop between the data we collect and the load simulator. In this video, we have covered the charge ladder, but these same principles regarding all the 5 steps and how to create a session and go through all the steps through the session apply to all the different charge ladders we have available, the sit-in depth test, and also the distant validations. The other sessions are more simple, but the same principle applies to all of them. So once you understand how to do a charge ladder all the way from step 1 to step 5 and get to the report, the same principle applies.